One of the things that distinguishes question 74 from 73 and 72 is the fact that it's not equal to 0, right? And the same thing happens with 75 and 77. It's not equal to 0, but it's still quadratic, and the technique is the same. It must be equal to 0 in order for you to apply the zero product property. We're not going to try to factor the left side here and make it equal to 15 because there isn't a 15 product property. No, there's a zero product property. But that's not complicated. It's just remembering that it's supposed to be equal to 0. So all you have to do is just add or subtract some terms to the other side of the equation. You can see that you've got two terms over here on the left, so it's pretty easy to just subtract the 15 over to the left side. So 12x squared plus 11x and then minus 15 is equal to 0. Now, whenever I do this, I want to make sure that my leading coefficient here is positive, just simply because if it's positive, it's easier to factor than if it's negative, which brings us to something like 75. On 75, it'd be quicker to just take this x squared over to the right-hand side to make this 0 equals negative x squared plus 12x plus 35. However, we don't like to factor with a leading coefficient as a negative 1. It's so much easier if it's positive. So at this point, you could just switch all of the signs, which is really just multiplying by negative 1. Or from the beginning, you could have just subtracted the 12x and the 35 over to the left-hand side of the equation. Even though it's, two things instead of one, it's still to your benefit because it's going to leave the x squared positive. So minus 12x and then minus 35 is equal to 0. Even though it's more, it's actually pretty easy to do because really whenever you're just moving terms over, they just have the opposite signs on the other side of the equation. Super easy. Okay, something similar is going to happen over here on question 77. Now back to 74. As a quadratic equation, I know that after I get it equal to 0, I'm supposed to factor this thing, right? And I'm also going to use the AC method because my leading coefficient here is supposed to be 12. So the AC method is called that because my first step here is to multiply this A term times this C term. So I would be multiplying 12 times negative 15 to get, oh gosh, some really big number, right? Okay, so the question is there another way to do this so I don't have to try to factor this number? Like, you can still do this. You could still multiply these two numbers together to get this obnoxiously large number that you're supposed to try to factor. But whenever these numbers get large like this, it's actually easier to do another method, which is called guessing and checking. Guess and check. Now, guess and check takes a little bit more experience and a little bit more skill to pull off, and it's ultimately faster than to doing the AC method. And it's kind of the go-to method whenever your numbers are really large because you go straight to the answer. That's assuming that you are comfortable with factoring and you know exactly what to expect as foiling backwards. Here, let me show you an example of guess and check in action. Starting with a random quadratic equation, which goes like this: 6x squared minus 17x minus 45, and make that thing equal to 0. Okay, now if I were going to use the AC method would dictate that I'm supposed to multiply 6 times negative 45. So negative 45, multiply that times 6, let's see, 30. 24, 25, 27, 27, so it's really a negative 270. Large number, I'm supposed to factor it. Well, if you have large numbers, you got to factor it. One of the things that you can do as a little tip is you could just make a factor tree, multiply any two things and multiply up to 270, like 27 and 10, and then just factor these down to primes, like a 2 and a 5, 3 and a 9, and a 3 and a 3. And whenever you're done, you just kind of pair these things up in different ways in order to find the factors that you're looking for. It takes a little bit more time, but it is doable. And this breaks it down for you in smaller chunks. Okay, however, I think it's faster and easier if we are just straight foiling backwards. In other words, I'm going to go straight to my answer, understanding that when I FOIL this out, these the two first terms are supposed to multiply up to 6x squared. So I'm asking myself, what times what gives me 6x squared? And there's a couple of different things that could work. For example, it could be a 3x and a 2x, or it's possible that it's a 6x and an x. And you're not sure which one it is, which is why this is called guessing and checking. You guess something, I'm going to guess the 3x and the 2x, and then I'm going to check to see if it actually works out. If it doesn't, then I have to go back and switch it to the 6x and the 1x. Let me get rid of those real quick. All right, now the next step is understanding in FOIL. When I multiply the last terms together, there's only one possible answer, and it's the C. It's the negative 45. So I ask myself again, what times what is equal to negative 45? Actually, ignore the negative sign. Just work with 45. I'm looking for factors of 45. So 45 could be equal to 1 times 45, 3 times 15, and 5 times 9, right? And I just have to choose the right one. Again, I have to just kind of guess which one I'm going to use. I'm going to guess the last ones in the list right here. And you're not real sure where they're supposed to go. So let's say, for example, I chose to put I'm going to put the 9 here, and I'm going to put the 5 here. Now you can kind of think ahead, multiply it in your head beforehand so you can choose the right location the first time, but maybe that doesn't happen, especially when you're first starting out. So whenever I did my foiling technique backwards, I've got my F taken care of, check. I've got my my L taken care of, check, with these factors that I have. The only thing that I didn't take into account is the outside and the inside, and that's where the checking comes into play. I'm going to multiply the outsides together, so 3x and a 5x gives me a 15x. I'm going to do the same thing with my inside terms. 9 times 2x gives me 18x. And then I have to see, is there anything that I could do, add or subtract, because I don't have any signs here, in order to get negative 17? Well, if I were to add these two together, it's way bigger than 17. If I were to subtract these, it's only 3. That's not going to happen. So what does that mean? It means that some of these factors are either in the wrong place or they're the wrong factors altogether. So I don't scrap everything. I'm just going to change the last thing that I put down. So I'm going to take away these things. And instead of this being a 9 and a 5, let me swap them. Don't change factors yet. Swap them. So I'm going to put the 5 with the 3 and the 9 with a 2 and see if that changes things. If it doesn't work out, then I would switch to, say, the 3 and the 15 and then switch places with that. If that doesn't work out, then I switch the 1 and the 45. If that one doesn't work out, then I have to go back to the 6, get rid of the 3 and the 2, and make it 6 and 1. Again, this is why it's called guess and check. And this might seem like it's a lot to do. However, if you're really good at multiplication, like mental arithmetic, it is way faster, especially if your numbers are large like this one. Okay, now let's check to see if this actually works with the new arrangement of my factors. My outside is 3x times 9 is 27x. In the inside terms, 5 times 2x gives me a 10x. Can I add or subtract these things to get 17? If I add them, it's 37. No. If I subtract them, I think I'm in business. So now I just need to think about the signs. I need it to be negative, which means the bigger of these two numbers has to be the negative one. So negative 27 plus 10x gives me negative 17. And now just follow the trails here to figure out which sign is going to be what. It's going to be 3 times 9 to make negative 27. And the only way that's going to work is if one of them is negative. So it's got to be the 9. And 5 times 2, it's either positive times positive or negative times negative. In this case, it's got to be a positive. And now I factored it. And the only thing left to do at this point is to use the zero product property. You go 3x plus 5 is equal to 0, or 2x minus 9 equals 0. In the second case, add the 9 over, divide by 2. In the first case, subtract the 5 over, divide by 3. And there's the 2 answers to my quadratic equation. And that's the kind of thing that you can try over here on 74 if it's too intimidating to try to factor 12 times negative 15.